We're asked to find the first four terms of the binomial expansion of 1 minus x to the minus 2. So I just need to replace my x here by minus x and my n by minus 2. This will give me 1 plus minus 2 times minus x plus minus 2 times minus 3 over 2 minus x squared plus minus 2 times minus 3 times minus 4 over 2 times 3 minus x cubed. This becomes 1 plus 2x. Then this and this cancel. The negatives cancel. Got lots of negatives going on, but actually I'm going to get plus 3x squared. And then the 2's cancel, the 3's cancel. Actually, all the negatives cancel. I've got, how many negatives have I got there? 1, 2, 3. I've got 6 negatives. So it becomes plus 4x cubed. And that is it. That is our expansion. And it's really nice because it's just seemingly going up by 1 every time. And actually, not just seemingly, it will continue because the next one round would be timesing by minus 5 extra at the top, but dividing by 5 would get a negative. But then when I have a minus x here, I'd get a negative and it would all cancel out. So you can very quickly say it's going to be 5x to the 4, 6x to the 5, and so on. So write down the term in x to the n. I've kind of actually talked about it, and you're meant to just sort of spot what's happened here, and you don't need to go into any more depth than that. Every whatever the power is, the coefficient is one more, and so write down the term in x to the n. It's going to be n plus 1 x to the n. We're now asked to write down the sum to infinity of this series here. Well, every time we increase a term, we're actually timesing through by x. So this is a geometric series. It's actually an infinite geometric series. A is 1, r is going to be x. So it's a sum to infinity, which in the formula is given in the formula book as a over 1 minus r. So it's going to be 1 over 1 minus x. And finally, hence or otherwise, simplify an expression for this. Now the hence bit is crucial really. We're going to be, it's going to be best to use our previous results. So we showed earlier that 1 minus x to the minus 2 is this, and that's very similar, except I've just got like an extra kind of 1 or x squared each time. So what I can do is write down 1 plus 2x plus 3x squared plus 4x to the 3 plus dot dot dot, and then see what I'm left with. And I'm left with 1 plus x squared. In fact, the series that I just figured out in part B. And we're nearly there actually, because we know that that one on the left is 1 minus x to the minus 2, which is 1 over 1 minus x all squared. And then we've just summed the second one. It's 1 over 1 minus x. We just have to put it over a common denominator, which is going to be the 1 minus x squared. So it would be 1 minus x at the top, and times on top and bottom by 1 minus x. And if I add these two together, that's going to give me 2 minus x over 1 minus x squared. Okay, nice question.